Welcome to my channel Circuits Analytica. In this video, we will be discussing about the operation of a bistable multivibrator using bipolar junction transistors. A bistable multivibrator is a circuit with two stable states. Circuit changes its state after the application of a trigger pulse. In a bistable multivibrator, the two stable states are Q1 off and Q2 on, state 1, and Q1 on and Q2 off, state 2. There are two transistors Q1 and Q2. Collector of transistor Q1 is coupled to the base of transistor Q2 through a potential divider network which consists of resistors R3 and R4, and collector of transistor Q2 is coupled to the base of transistor Q1 through a potential divider network which consists of resistors R1 and R2. This is the diagram of a bistable multivibrator. There are two transistors Q1 and Q2. Collector voltage of transistor Q1 is denoted as V01 and collector voltage of transistor Q2 is denoted as V02. Collector of transistor Q1 is connected to the base of transistor Q2 through a potential divider network which consists of resistors R3 and R4. One end of resistor R4 is connected to base of transistor Q2 and other end of resistor R4 is connected to negative voltage source minus VEE. Similarly, collector of transistor Q2 is connected to the base of transistor Q1 through a potential divider network which consists of resistors R1 and R2. One end of resistance R2 is connected to base of transistor Q1 and other end of resistance R2 is connected to minus VEE. So voltage at the base of transistor Q1 and base of transistor Q2. Voltage at the base of transistor Q1 is given as VB1 is equal to VBE1 is equal to V02 into R2 divided by R1 plus R2 plus minus VEE into R1 divided by R1 plus R2. Application of superposition theorem. Similarly, we can write voltage at the base of transistor Q2 is VB2 is equal to VBE2 is equal to V01 into R4 divided by R3 plus R4 plus minus VEE into R3 divided by R3 plus R4. Again, application of superposition theorem. Voltage at base of Q1 and Q2 when Q1 is on and Q2 is off. Voltage at the base of transistor Q1 is given as VB1 is equal to VBE1 is equal to V02 which is equal to plus VCC into R2 divided by R1 plus R2 plus minus VEE into R1 divided by R1 plus R2. This term is a positive term and its value is more than 0.7 volt. That is why transistor Q1 is in the on condition. So here we can say that the first term is the dominating term. So the second term minus VEE into R1 divided by R1 plus R2 is much lower than the first term. voltage at base of transistor Q2 is given as VB2 is equal to VBE2 is equal to V02, which is equal to 0.2 volt into R4 divided by R3 plus R4 plus minus VEE into R3 divided by R3 plus R4. And this term is a negative term, as the second term is the dominating term. Second term in the equation, minus VEE into R3 divided by R3 plus R4 is the dominating term. So that term is negative. So VB2 is negative. That is why transistor Q2 is in the off condition. Similar is the case when the multivibrator is in state 2. During state 1, Q1 off and Q2 on. Initially, let multivibrator is in state 1. Transistor Q1 is off and transistor Q2 is on. The circuit will remain in this state as long as the application of a negative trigger pulse at the base of the on transistor Q2. As Q1 is off, its collector voltage is plus VCC, which is coupled to the base of transistor Q2, which will keep base emitter junction of transistor Q2 forward biased. As Q2 is on, its collector voltage is 0.2 volt, which will keep the base emitter junction of transistor Q1 in the reverse biased condition. So transistor Q1 is in the off state. This is the diagrammatic representation of the bistable multivibrator during state 1. Transistor Q1 is off and transistor Q2 is on. And the circuit will remain in this state as long as a negative trigger pulse is applied to the base of the on transistor Q2. When a negative trigger pulse of very short duration is applied to the base of the on transistor Q2, transistor Q2's base emitter junction is reverse biased for a moment. So, transistor Q2 is turned off. As transistor Q2 is turned off, its collector voltage rises from 0.2 to plus VCC. As collector voltage of transistor Q2 rises from 0.2 to plus VCC, transistor Q1's base emitter junction becomes forward biased. So transistor Q1 is turned on. As transistor Q1 is turned on, its collector voltage drops from VCC to 0.2 volt. So now the bistable multivibrator is in second state, state 2. So this is the second state of operation of the bistable multivibrator. During state 2, transistor Q1 is on and Q2 is off. As Q1 is on, VCE1 is 0.2 volt, which is not sufficient to keep transistor Q2 in the on condition. So transistor Q2 comes out of conduction and is turned off. As Q2 is off, VCE2 is plus VCC and this voltage will keep transistor Q1 in the on condition. Circuit remains in this state as long as a trigger pulse is applied to change its state. So now we are going to apply a negative trigger pulse to the base of the on transistor Q1. When a negative trigger pulse of very short duration is applied to the base of the on transistor Q1, the transistor Q1 is turned off. As transistor Q1 is turned off, its collector voltage rises from 0.2 to plus VCC. As collector voltage of transistor Q1 is plus VCC, the base potential of transistor Q2 becomes 0.7 volt, or we can say that base emitter junction of transistor Q2 is forward biased, so transistor Q2 is turned on. As transistor Q2 is turned on, its collector voltage drops from VCC to 0.2 volt. As collector voltage of transistor Q2 drops from VCC to 0.2 volt, the base potential of transistor Q1 becomes negative. So transistor Q1 continues to be in the off condition. We can say that the bistable multivibrator returned back to the state 1. And the bistable multivibrator will remain in this state as long as a negative trigger pulse is not applied to the base of the on transistor Q2. To speed up the transition process, two capacitors are used in the circuit. Two capacitors are connected across resistance R1 and resistance R3, so that collector voltage of transistor Q1 and transistor Q2 are coupled to the base of transistor Q2 and transistor Q1 respectively. So whenever the bistable multivibrator changes its state, collector voltage of the transistors will change. Commutating capacitors, if connected, will form a differentiator in combination with resistors R2 and R4. The differentiator will speed up the switching of transistors from one state to another state. So by connecting two commutating capacitors, we can speed up the transition of transistors from one state to another state. Thanks for watching Circuits Analytica. Enjoy learning.